So we are
Nice.
live now. I'm here with Demystifying Science. This is Shilo,
Demystify Psi.
Demystified Sci.
Somebody stole demystifying science from under our feet, so we are no longer demystifying science.
Oh,
Yeah,
is
how
that
about that?
so?
We can tell you the story.
Yeah, that's
It's
that.
not a
Yeah,
good
we'll
story.
get into that. Shilo and Anastasia.
Mhm.
That's right. It's not. Sal corrected me. He's like, it sounds like anesthesia when you say it like Anastasia. Like the Russian princess there. Yeah, I like it much better. So I'm glad he corrected me on that. So before I got you guys on, and I mean it's also
Thanks, Sal.
been on if you watch your podcast, you also know that too. So, but sorry for the mispronunciation. I pronounce everyone's name wrong because it's just how I read things. It sticks in my memory like that sometimes.
I blame Disney.
Yeah, Disney, definitely. You guys have an awesome podcast here, and I want to plug it real quick if you don't mind.
Yeah, that'd be great.
Thanks, man.
Yeah, it makes sense. Only naturally. Let me bring up my screen. Sorry. Oh, and I have a friend. My friend Michael, I think, might join us too.
Nice.
You know Michael, Michael Perone. Windows. Let me see.
Yeah, it's just the Demystify Psi podcast stores everywhere. You can find us on YouTube or wherever the heck you listen to podcasts.
So maybe about like 2 years ago, we discovered that there was a channel, I think, from either India or Pakistan, where these guys were making medical illustrations of various bodily organ systems,
Like 3D renderings.
like
Really
3D
nice ones.
renderings, like super nice ones, and they were teaching everybody about medicine, and they were growing much faster than we were, and so we had to cede the name to them.
Yep, they won.
They won.
It's interesting that YouTube lets you have two channels with the same name, actually. Very bizarre.
Yeah, I wonder if you started another alien scientist and just covered Bob Lazar, if you wouldn't get madly more popular than me faster.
I mean, I think you just let the cat out of the bag. It's like a real loophole.
Hey, Michael, I can't see you so well, but I'm glad you could join us. Michael's works with me here in Massachusetts,
Nice.
and as a scientist, a very skilled material scientist. So glad to have him on board, and he's also a big fan of your channel. So
Hey guys,
Hey,
yeah,
Michael.
the other day you were talking about how the black body approximation is not very useful in a lot of situations, and I thought that was dead on, you know.
It's a bigger problem than most people realize.
Yeah, no, it's
A
like
niche problem, if I dare say, but it is a big problem.
Few know of this. Many are affected.
no, it's huge. It's absolutely enormous. It's like even like the barium sulfate stuff. Like if the black body were perfectly described everything, then barium sulfate wouldn't the barium sulfate paint wouldn't cool stuff down below ambient, you know, because it has it emits infrared in the infrared window, so um, it the atmosphere doesn't bounce back that frequency of infrared light, you know. So, are you guys familiar with barium
No,
sulfate?
I'd have to read about that one. I don't know much about that.
Yeah, it's just it's the specific spectra of it uh, has a peak in the infrared at a specific frequency that goes right through the Earth's atmosphere. So you can just actually you could, if you want, you could make a free energy machine right now. You could just, it's not really a free energy machine, but you could take like a Stirling engine and just uh, attach it to a little thing of water um, painted on top with barium sulfate paint, and just put it outside, and that'll start going because it's heat sunk to space effectively.
Just from the IR?
Yeah.
A Stirling engine is one of the ones that runs just off of ambient heat.
Yeah. Well, Stirling engines are highly efficient for small temperature differences, or as efficient as a Carnot engine for small temperature differences. or as close as you can get, pretty much.
Yeah, quick disclaimer, we are not engineers at all. We are like the hard bookish scientists, nature type people.
Well, try this. Get
that-
some barium sulfate paint. We can make you some. We have the ingredients here. Get some barium sulfate paint and get a Stirling engine and paint the bottom part of the Stirling engine with barium sulfate and just point it up outside and see if it starts moving.
Mm.
Interesting.
simple
Barium sulfate's also the stuff that they use for CT scans because it has such high contrast.
Mm.
Yeah.
In the radio frequency
Yeah,
spectrum that they
Yeah, it's
yes.
got a lot of useful applications.
I wonder
it's a
what
strong
frequency.
absorber.
Yeah, I wonder what frequency they're using for CT scans.
Oh, that's usually NMR. That's megahertz or high kilohertz or something. It depends.
Yeah, I was reading about these contrast agents. There's different ones they make you take, like for when you get CAT scans or other radiography that they help see stuff better. Gadolinium, right? Have you heard of that before?
Mm-hmm.
Mm-hmm.
Yeah, that's another.
Were you using this barium in a project?
We were gonna try to make some barium titanate and barium ferrite ourselves, so we got a bunch of barium carbonate. But it's simple enough to just mix that with sulfuric acid and get barium sulfate.
What were you trying to build?
Oh, all sorts of things. But I mean, yeah, barium titanate and barium ferrite supposedly have like I don't know what 0-point energy stuff, and we were seeing if we could validate any of those claims. If it does work, it's probably via a parametric effect, which turns the Neal relaxation or magnetic relaxation into a driving term for the LC oscillator circuit. So I gotta think more about that, but that's the general idea.
So you're trying to like harness the background hum of the universe somehow.
Well, in this case, we're just trying to harness ambient thermal energy, and this one would directly violate the second law of thermodynamics. However, the second law of thermodynamics has some implicit assumptions that don't always apply, and there are a few proofs of that now. There's
what are the assumptions that don't apply?
The main one is ergodicity, which is a statistical property, which generally means that all states are roughly of equal probability of being accessed by quanta of energy and stuff. So that basically means that energy will spread out over time. So if for example, you talk about the stock market, it's not ergodic because the amount of money a person will have in the future depends on the amount of money they currently have, or the likelihood that they'll have more money is influenced by the current amount of money that they have. So
ain't that the whole universe basically?
Yeah. So that's not ergodic. But if you imagine like a single particle in a gas, the likelihood that it has more energy in the future does not depend on its current state. Most physical systems are like that. However, not all, and a number of those systems, basically, there's something called the Redfield equations where they make this assumption of weak coupling, quantum mechanically speaking. So if you have two particles like an enzyme, like you have a receptor in a cell and you have a binding thing, those two objects come together with some high probability, and that is because there's some quantum correlations that happen between them. And
what is that? What do you mean by? What do you mean?
So maybe
like the way that I kind of imagine that is that they have some kind of shared resonance that allows
together.
them to come together.
Yeah, actually, that's not a bad way of putting it. It's there's these things called phonons, and also there's also polarons depends on.
I know phonons. Phonons are like waves in matter, and then
It's basically,
polarons.
yeah.
So polarons is just a way of describing how these phonons interact with polarization of the molecule, in terms of electrostatic. But so they're almost identical to phonons, but they can exist in like liquids and gases in principle, I think, or
What about
mostly.
phonaritons?
So, but
And
They're
does
like
it have to do with
polaritons.
like?
there's all sorts of quasi-particles, but point is, you have mechanical vibrations of these two molecules, and that kind of they fit together,
That
and
makes
those
that makes
vibrations
that makes
kind
a
of
lot of
help.
sense. That makes a lot of
But
sense. There's
when but
so
when
there's
those
this
so go ahead.
there's this really interesting concept if you go back into the early days of physics. So after Newton's figured out his force equations, and they have this moment where they're like, "Oh shit, chemistry doesn't work with atoms," because like they know that they can mix together atoms that will make chemical compounds in some cases, but not in other times. And they also have this model of atoms where they're like, atoms are indestructible objects. And so indestructible objects, by definition, axiomatically also can't be deformable objects. So you have these, because they're the bottom of the universe, like something that's not made of component parts can't deform. And so this guy, he's a Jesuit priest. His name's Boscovich. Boscovich is like, I have figured it out. There's actually no such thing as atoms because they are incomprehensibly paradoxical. There's only point particles with these areas of force around them, and only molecules that have the corresponding compatible force fields around them are going to be able to interact, which
Wow,
is kind of
that was a very early, uh, that they got at that really without much.
this was like 17 like 20, maybe even
That's not
earlier.
bad.
But it's crazy too because it's like it doesn't make it, the atom is obviously like a thing, but he is speaking to this idea of
He's speaking to the engineers in the room.
to the compatible resonances, which I think that there is this germ of truth there where I'm like, well, there's definitely it's not force fields. I don't like force fields. How do you guys feel about force fields?
Well,
Probably works for engineering.
I mean,
Field
fields is
theories.
more general. Fields is more general. Depends. I mean,
Sorry, I was just gonna say, force field. I think of like matter is like a form of trapped light, a light that no longer has this that infinite time where you're now actually bound in time, and traveling in a circle.
I've tried to explain this to Jeremy in the past. What he means is light is a phase change in the vacuum, which occurs when there's sufficient energy density for virtual particles to overlap their past and future light cones, so that you add a nonlinearity into electromagnetism, which produces solitonic results, and those are particles, roughly speaking. And that's a rough way of understanding the electroweak unification, but I need to put more math to it to make it more formal, probably.
Or less. So, like, full disclosure, we're working on a book right now where we're trying to explain these quantum processes not in terms of math, but actually looking at the math and saying what the material actors could be doing. So there's a different way of looking at these things too. Like a field is really it's a set of vectors essentially that change quantity with time.
And you have a metaphysical question: is the field fundamental, or is there something below the field?
Yeah, like the field's talking about something doing something. And so there's this wonderful question that's not particularly practical for engineering necessarily, but it's an interesting curiosity. Like, what are the fields pointing at? What is the substance, and what motions is the substance undertaking to do these, apparently magical phenomena like light and gravity and electromagnetism in general? And,
I'll quote Einstein, I think, as simple as possible, but no simpler. That's
Yeah, and I mean, when you start to get into fundamental physics, that's as simple as possible becomes really difficult to parse because I feel like everybody has a different set of things that they're trying to explain. And when you start to fold different events onto each other, like we're talking about phonons and polarons are phonons, but they include polarization. And so all of a sudden you have to explain like a bunch of different things at once in order to be able to have some cohesive sense of what is actually happening inside of your system. And so I don't
Right.
know. I wonder,
And
as engineers,
communication is hard.
A lot of it's based on the formulas that
Oh,
we
go ahead.
all learn in school, your foundationals, which is,
You were going to say, though, she was going to say something.
I know, I was gonna say, like, how much time as engineers do you guys spend thinking about what the equations mean versus what the equations are?
I
Well-
mean, depends how much you're doing R&D, probably.
Hmm.
You mean in terms of the material actors, the architecture of the atom and stuff?
Yeah, like if there's like a,
Because I think there's like about 5 people in the universe who think about that.
Yeah, ontology is not the field of engineer so much as a philosopher.
I wonder about that. So something that Shilo and I used to argue about a lot was like, what comes first, science or engineering? And are they related? Are they truly related?
Well, a lot of good science was done by accident while engineering. You just have to be open to the possibilities.
I mean, there's certainly cases where it does, right? Like you can, and it can go the other way. So you could be studying some molecule in some, mold or something and come up with a technological solution. Like you end up inventing antibiotics or something like that happens for sure.
Yeah, like
But a lot of engineering is just trial and error. Like you don't actually have to necessarily understand nature's magic so much as be able to parameterize it and make equations to describe the phenomenon in like a repeatable way that matches your observations and predictions.
true.
It's interesting how different those two practices are.
Yeah,
So,
I mean, yeah, understanding on a mathematical understanding in terms of a practical heuristic model versus something that's truly fundamental. Maybe there is no fundamental model. I mean, a lot of people want to get to a grand unified theory, but even if we did find one, is that just like a model that we made to, like, that's the thing. Like people always talk
those
about
models are mathematical too, though, right? So that's not exactly what we're talking about. So we're talking
well,
about the substrate
well,
that the math is
so how do you
describing.
know? How do you know that any given mathematical model actually represents the universe? Yeah, I don't know. I tend to be of the opinion that in terms of mathematics, at least, uh, we use mathematics to as a language to communicate ideas, and it has no like there's no mysterious like strange uh, unreasonable effectiveness of mathematics at describing physics. It's just physics has evolved along with our mathematical vocabulary for describing and communicating these things.
But
And you can see that even today. Like
and
now,
it's
a lot of
really
people are
good at
talking.
describing is the thing. Like it's really good at making those descriptions, but it doesn't. It's unable to explain is the thing. If you want to explain, you have to actually accompany it with English to basically point at what those actors, what the variables are, explain what they mean. Like you have to interpret the math, and in order to say, hey, this math is talking about a ball that's moving in on a planet, and there's this thing called gravity happening, right? So it's like the math is extraordinary for describing the scene, but it doesn't actually explain what the ball is doing to be pulled to the earth at the same time.
Like this came up a lot when we were talking to Sal, right? Like we're talking to Sal about his anti-gravity devices, and it's like, how well do you need to understand the cause of gravity in order to be able to manipulate it?
And the answer is not at all, basically.
Yeah, and in principle, you could stumble across something. The issue being that you have if there's a coupling term in this area, it's g over c to the fourth, which is tiny. So the likelihood that you're going to see a large so basically you need a large amount of energy in a resonant system that has a third or fourth order nonlinearity in order to be able to see a large effect. So those like in just in terms of being able to overcome that g over c to the fourth term. That's
and so like the material analog of that would be the inverse of that, which is like approximately the elasticity of the system. And so you're talking about how easy it is to deform it, essentially, which is that it's extremely stiff, is what you're saying. It takes a tremendous amount of energy to deform.
Well, yeah, what I'm saying is also the likelihood that something that so there's when you get into the higher order nonlinearities, there's fewer and fewer materials that have a large nonlinearity of that type. So, and then you need to know how to efficiently resonate that without many losses, which is also so the constraints on this engineering possibility of just randomly discovering it are quite extreme compared to most other things that people have just stumbled across.
It's a hard system to play with without big guns, basically.
Yeah, it's definitely one of those things that will probably require a lot of deliberate and careful engineering to even figure out what we're talking about. Like it's, I think gravity stuff, except for maybe some very, very simple stuff like T. Townsend Brown was, I mean, apparently his family published a website of all of his old research. And one of the last things that he was doing before his research went dark, like he was looking at different elements and isotopes and measuring apparently differences in their gravitational and inertial responses under very specific circumstances. So like there might be some natural weirdness like that to some extent. But those effects would also probably be very small for similar reasons. So you need very sensitive equipment, and then you have a similar problem again.
So is your guys' ultimate goal to be able to design something that works by influencing gravity to provide propulsion and levitation?
Well, my goal is more on the energy side. I think that, like, at least with the Alternative Propulsion Engineering Conference, they're very propulsion focused. I think personally that energy is more important. I think it's honestly a little bit funny that, well, at least a little weird that everyone just kind of assumes, okay, Earth's probably screwed. We have to get off of Earth. Like that's, and then they assume like, oh, that's probably going to be easier than just figuring out how to live sustainably. You know,
we got those asteroids coming. That's the thing I'm scared of. Every 60 million years, like clockwork, it's just like boom.
Elon's rockets are just taking too long, man. We got
that's true.
a better
That's
way.
True too.
But it's funny how people think that the best way is to like, oh, let's make anti-gravity. We'll figure out propulsion, and everyone's focused on propulsion. When Michael, if you were to have like some crazy new source of energy, it really doesn't matter what kind of propulsion you use because once you get the energy, you can figure all that out.
Yeah, the energy is more like energy is the final. Like nature has shown that matter is recyclable pretty much infinitely. Like otherwise the ecosystem wouldn't have survived as long as it has on Earth. So energy is our only truly scarce resource, in a sense.
Why do you think it's scarce? Do you mean that burning stuff is not sustainable, or like the energy of the universe certainly isn't about to run out? Like, do you mean just on Earth we have limited ways of capturing
usable energy? So like light from
power
the sun
harvesting
that plants use and stuff. That's up until recently, maybe. I mean, the hope. One of the hopes is, with some of the work we're working on is that if you can have strong coupling with these polarons and things that I was talking about, and basically strong coupling in systems, in quantum systems, basically avoids ergodicity. So actually, there's a lot of strongly coupled electron matter, like what's it? All sorts of in material science. Strongly coupled phases have non-ergodic energy distributions potentially. A lot of them kind of like when you go from the particles to the quasi-particles, you have an effective theory that's still ergodic, but there's a few edge cases there. But yeah, a point back to the general stuff is if you can recycle ambient heat, then just like matter, then energy becomes recyclable too.
Is
And
the alternative just losing it to radiation out to outer space?
That's a good question.
I think I mean, so I think that probably it's physically possible, according to everything I've seen in the past couple of years. I think that it probably was not evolutionarily dominant because the power densities compared to photosynthesis are somewhat lower, and the overhead of like machinery that you have to construct is higher.
Mm. You mean for like
So
for harvesting heat energy?
yeah, and in fact, some people think that maybe there's like thermosynthetic life deep enough in the earth, which is an interesting possibility.
There's
You know,
definitely really
water's a
crazy
really
stuff.
good absorber in the IR too. Um, and you can get a lot of energy by looking at how this heat is dissipated in evaporation. I know there's some really interesting projects on that end.
How do you know that, Shilo?
Shut up. Yeah.
This
We
is
used
what
to build
Shilo's
these
studying.
machines in my lab a few years ago, and
Well, towards
uh,
sustainability, I saw something really cool recently, in terms of water sustainability, at least.
yeah,
Um,
it's really cool because you slow down
so
evaporation by harvesting the power of evaporation. You actually slow it down, which is good because all of our reservoirs are drying up. So if you could put
interesting.
if you could
Well,
moderate the
no,
evaporation, you could suck off a little bit of that lost energy from the radiation.
I don't necessarily agree with that. So there are these evaporating systems that people have been looking at least on the drawing board, where you basically have like an HVAC thing that goes deep underwater, like 30 or more feet, and you just flow humid air through. Like if you're in India or something, you just flow humid air through this system under the water, and down like 30, 40 feet, it gets quite cold. It's just water has a huge thermal mass everywhere in the world. So um,
Yeah, I was
down
talking about like surface-based devices where you actually
right,
just
yeah.
stop the
So
evaporation
this
at the
is
surface.
more efficient because you don't need to pump anything. You don't need a compressor. You're
Yeah.
taking advantage of the whole surface area of the ocean.
Yeah,
Um,
we built some proof of concepts. They were pretty impressive, actually.
really,
The energy density was we actually used a biological substrate that basically swells in the presence of humidity gradients, and
hmm,
it was pretty promising. The problem
that's
is nobody
cool.
wants to cover their reservoirs with this stuff. It's like, you know, it's funny 'cause, we thought the whole world would be really excited about this, and, you know, my PI went on a tour out to the West Coast to try to sell some different California townships on this technology, and the boaters, man, the boaters showed up, the ski people, they were like, "Hell no, you're not covering our reservoir." It's like, "Alright, end
There's
of
a
that."
long and storied history of natural places being developed for recreation, and I don't think that any amount of clean energy is going to get people to let go of their jet skis.
Yeah, I just have the same worry about bike trails. I like bike trails. I bike a lot, but I worry that we're dismantling important railway infrastructure and replacing it with something a lot less practical at
Mm.
scale.
Are the bike trails along railroads often?
Well, usually you have rail trails. So when they dismantle an old railway, instead of replacing it or building up something on the side and then a bike trail, they'll just replace the railway with a bike trail and call it a
Oh,
day, which
that's
a
kind
lot
of
of people
interesting.
like, but they should really put a railway next to the bike trail. Anyway,
Wait,
um,
I mean, there's a really top-down way that this stuff usually works. I've been reading. Do you know who Robert Moses is?
no idea.
So Robert Moses was this baron of public works in New York City in the 20s, and he built basically all of the New York State parks, all of the parks on Long Island, a bunch of the parks in New York City. He built the New York City highway system.
Central Park. Didn't he redo Central Park?
I think he might have redone Central Park, but there was this huge conflict between what to do with the stuff that was there, right? Like people wanted it to be remained as forests and as nice lands. And he came in and he was like, "No, we're gonna have baseball diamonds and bathing houses." And now it seems like the next level is, well, we had all this infrastructure. The infrastructure has decayed since we built it in the 20s and 30s. Now we might as well just raise it to the ground and just build a bike path, which is kind of a funny.
Well, the problem
funny
is
art.
that a modern society's fundamental limitations on standard of living are the amount of energy per capita and the amount of infrastructure and heavy machinery per capita. Because if you
Mm.
have both of those, you can provide like however much you need to survive. But once you start taking away infrastructure, taking away energy, then you're shooting your productive capacity in the foot. And yeah, I mean, generally speaking, a modern economy's production capacity scales with energy and machines available, not with amount of people available.
Hmm.
So it's a concern, you know. We're not.
We're certainly going to have less people available, it seems like, in the next few generations, at least in this country.
Maybe.
If-
I mean,
Hmm.
that's. I don't know. I think
It
it's
depends on immigration.
We'll have robots.
It's a little short-sighted, I worry, to make those decisions ahead of time without knowing for sure what the population's going to do.
Have you seen the reproduction graphs?
I have.
I mean, nobody knows the future, but these charts are kind of incredible.
You're the first
That's
person
fair,
that
that's
I have
fair.
heard express optimism about this. Like, so you don't think that we're basically on the long slope towards
So I think
like,
that
having a population?
industrial countries, it's like 2 kids barely, if that.
Dude, it's
like less than that in the United States.
I think South Korea is 0.7.
Well,
If
I
you
mean,
want to
other
bring
areas
that
of the
up,
world,
I'll let you share your screen if you want to bring that up.
other
I was
areas of
just
the world
looking
have
at.
yet to catch up with that, though, and that's
I
a
had
blessing and a curse.
I had that footage of the Townsend Brown 50s anti-gravity experiments running in the background. This was September 1957, and they have barium titanate written up on the board right here.
Mm.
That's pretty crazy.
So what's the basic principle that the barium titanate is harvesting energy from the ambient environment, and that's powering the device in some sense?
No, T. Townsend Brown was making a device, an electrogravitic device. So he had some shaped electrostatic fields such that I mean the idealized simple version is, imagine a capacitor where one plate is like a wire or a nail and the other plate is flat. Now the flat plate, you're going to have all your field lines flat on that surface. Simple enough. Now the plate that's a wire, a lot of your field line is going to be concentrated on the tip, so it could arc, but a lot of the field lines will actually also be on the side of the wire. So now the sort of idea, and it's not, this isn't an ideal description either, because it's pulsed DC, so there's some relativistic stuff going on. There's like some interaction, but basically your field lines are on the side there, so you're providing a negative pressure on the sidewall instead of a static pressure against the other plate. So the idea was you have an unequal force on the two plates. And there were other ways to explain this. But yeah, so when you pulse this thing with relativistic effects, then all of these things, all of this flat plate is roughly affected all at the same time, and then the effect kind of washes over the other side. So there's this non-reciprocal force apparently that comes out of this. But
so are you pushing against the plate in that case?
Ourselves, I think we've been talking to one guy who has been able to supposedly replicate this. I think he's got an ionocraft. I don't know yet though, so I want to replicate it myself first, but we have other projects that are more pressing.
Yeah, what is the stuff that you guys are working on most pressingly right now?
Again, energy. I mean, as long as we have an so the thing I was going to mention a little bit earlier was um, it's kind of funny that everyone wants to get to space and they think that's going to be the easy way out. But then when you talk to people about how about figuring out how to actually live sustainably, you don't need warp drive, you don't need crazy amounts of antimatter or anything. You just need good old fashioned engineering and ingenuity. And everyone's like, no, that's no longer possible. Like, no, there's ways. There's ways, I think, and we can live more sustainably with the world we have here. But anyway,
And so
yeah,
what's the energy
energy and
stuff that you guys been
sustainability.
working on?
Yeah. Oh, sorry. What's that?
I said, what's the energy stuff that you guys
Like
been
the
working on?
specific projects?
Yeah, like the specific projects.
Oh, there's all sorts of things. Yeah, most of these are thermal recyclers, like I was talking about. Um, like a few of the ones that are on the web are, yeah, Daniel Sheehan here. He's got a whole bunch of examples over at the University of San Diego. If you want to look through his research, he has 2, 3, maybe 4 different example systems now that all do this.
Hmm.
With some replications in other labs. We're trying to replicate one of his systems. We're like halfway there. We're getting we have this device with a persistent pH gradient, and now we're trying to take that pH gradient and turn that into electricity. And it's not easy. I think we have the wrong electrode materials or catalysts or something. But at the very least, we can verify that this pH gradient is persistent, even when you carve a flowback channel for equilibration in the thing. So that's interesting. But what was? Oh yeah, and then the other main one that I've seen is the graphene energy harvester from the University of Arkansas. Paul Tabata worked on that one. And there's also on YouTube. I think it's a now defunct conference, but they ran for a few years, and actually Stephen Wolfram attended, which was pretty cool. It's called the Unlab on YouTube. Jeremy, put that one up. The Unlab. Maybe the YouTube page if you can find it, because I don't know what the deal is with. Okay, it's still, yeah. That's the right logo, I think. Oh, hey, it's an MIT lab. I didn't know. That's good. All right, so that explains why Wolfram went, because he's nearby.
And do you know what it was about?
Yeah, what's their project?
Well, the Unlab talks about all sorts of bleeding edge physics stuff. So, like all of these thermal recyclers. Some people claiming vacuum energy conversion. There's a few ways of conceivably doing that as well, actually. I mentioned, well, at least online, I've mentioned in the past parametric effects and stuff. Well, there was this one guy with a very clever idea where if you have a transistor on one side and you have a Casimir plate levitated on a spring, then the Casimir force depends on these plates being conductive. But if on one side you have this transistor-like thing, so you can change its conductivity, you can change it from conducting to insulating, then you can change the Casimir force between the plates by switching the transistor on and off. And if the energy it takes to switch the transistor is less than the energy, this potential energy in that change in the Casimir effect, then in principle you can use that to tap vacuum energy. Lots of cool ideas.
Why would there be a delta? Is it a delta G?
It's just because the Casimir engine is somehow harvesting the background.
Well, that's the claim. I don't know about that, but what I do know is if you have two conducting plates and you can switch one from conducting to insulating, then the Casimir force between those plates should change, and therefore their equilibrium spacing, if one is attached by a spring, will change. And then if you switch the thing back, then you just repeat that cycle. And the switching of the conductivity to insulating state of the transistor will not depend on the position of the other plate, as far as I know.
Do we have a good sense of why the Casimir effect works?
Yeah. You have a boundary condition on vacuum fluctuations. So only certain vacuum fluctuations can exist in that gap because you have the two conducting plates. So those conducting plates will screen out any other, like they'll dampen out any other waves that aren't, lambda over, what was it?
It's like phase
UM.
cancellation, I suppose. We had this dude from University of Plymouth on our show, Michael
McCullough.
McCullough. Yeah, he's building
Oh,
some.
yeah. He's good.
Yeah, he's building. I guess he's having some success building, proof of concept versions of these Casimir.
Yeah, his
Uh,
stuff went dark, right?
oh yeah.
He got like, he's got well, for a while, I think. Now they have a company. Jeremy, did you have a link to that company still? I forget the name. Yeah, Mike McCulloch, he had this device with some spinning discs, and he had this theory that if you spin these things fast enough, then their Rindler horizons or something like that
Mm-hmm.
are near enough that you can push off of those information horizons or something along those lines. But yeah, I heard from Jeremy recently. Apparently, they've got a company and they're testing something in space now.
I think that they've been working on that, yeah, for a while. McCullough also just he published a book of fiction. He just published a big paper. He's trying to get a job at Oxford. He's really trying to get things going for himself.
That's
I think.
nice. I mean,
mean,
yeah.
go ahead.
With all he has a good idea, and I think it sounds like he got positive results, and with that came a lot of funding and probably some NDAs. Sadly,
Mm-hmm.
so
Yeah,
that's all.
that's definitely true. I'm still trying to piece together. So it's like the Casimir. How do the plates shields?
Have you guys seen this yet?
Jeremy, if I may. So imagine if you have a plate, if you have a wavelength that's not equal to the distance between the plates or
It
some multiple
doesn't show up
thereof.
in between the plates because it's a
Well,
quantum.
yeah, imagine it's like
Phase cancellation.
halfway through a plate.
Yeah.
Then there's going to be an electrical eddy current in the plate because the plate's conductive that dampens out that wave until it's not. So you can only have nodes at the edge stably.
I
See what
see.
I'm saying?
Yeah. Yeah, that makes sense. Okay,
Yeah.
Jeremy, what were you trying to show?
Oh, that was the company that's launching Mike McCulloch's test drive. So I don't know if this is Mike McCulloch or Roger Scheuer, because Roger Scheuer was doing a bunch of stuff with this, and I just thought that was it's very similar, but I watch it. I know Mike McCulloch shared it, so but is this the M drive? Is that this is a different system, I believe, but they're testing the principles of quantized inertia with this system, and apparently they did exhaustive testing on this thing on the ground already, and they're ready to put it in space. Yeah, this is the key part right here. So I'm gonna put the
Oh, it's
volume.
muted.
Let me actually, I gotta share the volume. Let me pull it out and then reshare it. Oh, Bernie's here too, by the way. He's somewhere in the background there.
Good timing because I got to get going. Actually, I'm trying to get my sleep schedule back to normal. So
good on you, Perone. I struggle with that every day. And I just wanted, before you go, excellent points on we need to figure out energy here and sustainable living. It's just so ridiculous to be like, oh, let's get to space where it's so uninhabitable, and without unlimited energy, you're pretty much screwed. As opposed to, let's make it happen on Earth first, and sustainable living.
Yeah, exactly. Like if you don't think you want to live like under the ice cap in Antarctica in a little dome, then how do you think you're going to live in space any better than that?
That's a fair point.
It's true, man. And then all this work we're doing for what if we do create a warp drive and all we're doing is giving it to the, the people who are just going to use it for war and haven't fixed the problems on this planet first. So
Gotta open source that shit.
yeah. Heck
Well,
yeah.
Apex all about
sustainability stuff at least.
A chicken in every pot, a warp drive in every garage. That's a platform.
Well,
Warp.
anyway, yeah. I mean, we need to get to sustainability. Actually, yeah. If we can achieve post scarcity, then a lot of the impetus for war goes away in the first place, because there's no scarce resources to fight over really at that point.
Except ideologies.
Yeah, I was like
Well,
that.
yeah. I mean, there's always that, I suppose, but I mean, through most of recent history, the big wars with major powers have been over, secular, like, oh, there's an oil pipeline here, this thing there, But anyway, yeah, at the very least, it'll help reduce conflict somewhat, and then, well, yeah, I mean, if we don't take care of our shit here first, then we're gonna just take it to space, and we may be able to get out of the gravitational field of the Earth, but we won't be able to escape our natures.
The nature field. It's true.
Yeah, the big thing in our area is those super fun sites, man. It'd be great if we could find technology to clean up all those messes that we've made instead of just being like, all right, let's go and make some other place and turn it into a shithole.
Yeah, did you see the thing Sal Pius mentioned?
Yeah.
Oh wait,
Yeah.
no, that might have been after the show. Let's maybe wait on that a little bit because I don't know. That was in like kind of the after party thing, I think.
Yeah, it wasn't anything too crazy, but yeah.
But yeah, there's ways, there's
Let's
ways
blow
of
some
taking-
state secrets. Come on, guys. What are we doing?
Well, there's ways of taking these nuclear, like radioactive waste and breaking them down. There's ways of doing
He
it.
mentioned it on your show, the Mossbauer effect and stuff.
Well,
right?
I mean, yeah, at least the stuff that's publicly available is a couple of years ago, a guy named Peter Hagelstein was working at MIT in the he went to the cold fusion conference and he was reporting on
It's from cold fusion.
Mossbauer effect coupling to induce cold fusion. So the idea here is the Mossbauer effect is, yeah, I guess, Jeremy, we can talk about what's publicly available. Why not? The Mossbauer effect is basically if you have a gamma ray that's coming in, hits an atom, the atom's going to go flying because of the momentum of the gamma ray. So if you have an atom that's in a material lattice, then that same kinetic energy, instead of going into that single particle, will spread throughout the crystal lattice. So you have a coupling between this very high energy gamma ray and phonons in the lattice, thermal phonons in the lattice. And I mean, you can see this in many ways. So there's a gamma spectrum of various materials, like some of the isotopes of iron. And this gamma spectrum, if you heat stuff up, you get line broadening and all sorts of effects like this. But what Peter Hagelstein showed in an experiment a couple of years ago was that you could have nuclear excitation transfer between atoms of tantalum. So nuclear excitation transfer is where you have a nuclear excited state, typically in this case called a nuclear isomer. That's where you have a nucleus that combines with a gamma ray and forms a metastable state that eventually decays and releases a gamma ray again. But for a while, this gamma ray is trapped in the nucleus like that. So you have this nuclear isomer, and it's an excitation in the nucleus of the atom. And if you have a population of these in a chunk of tantalum, he showed that actually these things diffuse and migrate through the tantalum as if they were jumping from nucleus to nucleus. And that can only...
Like a nuclear current.
Sorry, what?
It sounds like a nuclear equivalent of current. almost.
I mean, it's not like electrical current,
Right.
but it's certainly like electron hole pairs, like excitons. That's probably a decent way of a more decent analogy on. But so if you have this coupling, nuclear excitation transfer between nuclei, then what that implies is there must be a reciprocal thing. So you have the Mossbauer effect where a gamma ray comes into the atom and gets trapped and releases a phonon. Then if you have nuclear excitation transfer, that means the inverse must somehow also be true. So if you have a phonon in a lattice, you can stimulate the emission of a gamma ray from a nucleus.
It's like,
So
I'll buy it. I mean, if you have a sufficiently concentrated, focalized, right? Because it's
Like the surface of the sun or something.
well, it's just the reverse of a process, right? So if you have something that's hit by a gamma ray and it diffuses, that's
exactly.
dissipation as opposed to concentration, which you're working up an energy gradient to produce. And so that seems
Exactly.
like it'd be a lot harder. It seems possible, right? Because they are reversible processes.
Mathematically, it was not trivial at all to show that it was a reversible process. However, all the same, it apparently is a reversible process. And what that means is, in principle, you can take like radioactive waste and figure out what Mossbauer spectra to like what phonons to hit it with, and you can actually cause it to decay. And that can, I mean, I won't go any further than that.
Oh, so you're saying that instead of having to wait for its natural rate of release of gamma rays, basically just hit it once, have it just go like poof, lose everything at once, and then it's no longer radioactive?
Yeah, pretty
Doesn't
much.
that transfer radioactivity into the container though? Because like if you have like let's say you have the
Oh
stuff.
yeah. The radioactive output of that would be pretty intense. And that's kind of
Are we really solving something here, guys?
that's kind of probably part of the problem with like so that could the worry is that could be weaponized too.
You'd have to
And
like
it probably
Anything can be weaponized.
Yeah, anything can
it
be
almost
weaponized.
certainly has already been by the US at least.
You'd have to like
There's
find some way
I mean,
to dissipate.
Jeremy,
They weaponized compassion.
What about
Jeremy,
thorium?
there's that other publicly available info. What was
What
the name of
about
it?
thorium?
The what was the hafnium controversy? That's still up, right?
The hafnium. This sounds like an Agatha Christie novel. The hafnium controversy.
Doesn't it though? Yeah, there you go. It's still on Wikipedia. They haven't taken it down. Anyway, a couple
Did you
years
guys
ago,
hear Graham Hancock on Joe Rogan the other day where they were talking about Wikipedia and Hancock was like trying to find the words to describe what he thought about Wikipedia and he was like, Wikipedia is an encyclopedia of lies.
Well, not in this case.
Good.
Then he referenced it like an hour later.
Actually, yeah, Jeremy, maybe put this hafnium controversy page up on like on a archive or something. Actually, maybe I'll go grab it too right now. But yeah, so basically a bunch of nations accused the U.S. of having a hafnium-based nuclear isomer weapon, which that would be terrifying if true, because it's not like it's much more subtle than nukes. You could basically shoot gamma rays through the earth and just sterilize a whole city, and everyone would just like have no warning and they drop dead. And it's traveling at the speed of light, so how do you like? You're not going to get any advance warning. It's going straight through the earth. There's no faster path.
Wouldn't you also I mean, like, if the energy, how would you possibly protect yourself from the production of that kind of radiation? It seems like it would just sterilize you as well.
There's no warning. It travels at the speed of light.
No, I'm saying like the people who are making the weapon.
It's collimated. So you would make a laser. You would have a. I mean, there's not.
Didn't they try this in Star Wars?
No, this isn't Star Wars. I think
that's Alderaan didn't do so well.
No, so you would effectively need a mirror for gamma rays. So that would be difficult, but not impossible to engineer because you have the Mossbauer effect already. So, but if you had a mirror for gamma rays, you could produce effectively a laser.
They can do them with X-rays with like these really low angle incidence rays. They just have a series of really low angle.
With gammas,
Mirrors,
I think the
essentially.
only thing is beryllium.
NASA says that gamma rays cannot be reflected by mirrors.
Well,
Yeah.
that's you can have total internal reflection in beryllium, I believe.
Interesting.
extent.
What's special about beryllium?
I'm not sure actually. I've always wondered about that myself.
Yeah, it's a neutron reflector too. So
Yeah, it's a very interesting metal, that's for sure. Very toxic too. So I don't want to play with it personally, but yeah, I mean, so if you have the Mossbauer effect, then in principle you could also make a mirror for gamma rays of specific frequencies. Maybe. It's a stretch. But anyways, that was the concern a few years back, is that they had this hafnium based weapon or something.
Who they? Just like the they?
DoD.
Yeah. DoD.
Interesting.
Someone at least.
I'd be more worried
could be a
about China
private
having
company.
it. But let's
But,
say
There's Putin talking about these new weapons with new physics principles.
Oh,
quote
God.
This is one of them.
God.
if there's one person who would use them, it would definitely be Putin. That dude, he's got nothing to lose.
I don't know. I think I mean
no, it's World War III. I really think
at this point, all these leaders are crazy.
Yeah, but they're all working together behind the scenes at the end of the day to clear out their arsenals and sell more tanks.
Right? Like Russia's still providing 3/4 of the oil to the Ukrainian army.
Is that true?
Really?
Yep.
That's wild.
What a deal.
Yeah.
Yeah, why is beryllium so anomalous? Like, I'm looking at it, it's not a huge element. It's just
it forms polymers, you know. It can make polymers, unlike most metals.
It's a weird one. Is it S shell metal too?
It's an S shell metal. Is that unusual?
So it's kind of strange.
That is very unusual.
This is like, isn't the beryllium the stuff that they made beryllium powder, and if you breathe it in, it's like instant cancer, and that's what tons of people there was like someone that researched it, and then all those people who were researching it died of beryllium poisoning and cancer.
If you're not willing to die for chemical poisoning in the name of science, are you really even a true scientist?
Yeah, Mary Curie.
That's what I'm saying.
No, she got 2 Nobel Prizes.
Right.
Mary Curie's notes are still radioactive.
Wow.
I think actually, honestly, a good degree of caution. I mean, I'd rather live to see another day and do more science. You know.
Yeah.
When given the option.
Well. Anyway, I do have to get to bed. I don't want to mess up my sleep schedule again. I just got it back on track. So.
All right.
But very nice to meet you both.
Yeah, it's nice talking to you, man. Have a good night.
Get some rest.
Thanks for being here, Mike. Can we go into thorium a little bit? Because, isn't it like a cleaner alternative to unlimited nuclear power?
I think it's less prone to these runaway reactions.
Is that it? Oh, and you can also there's a huge amount of thorium in salt water.
Yeah, it's in the ocean, I think, is the good news.
Yeah, I have a guy who's like all about the thorium stuff. I gotta have him come on. I forget his name. I got a whole list of but this is Demystifying Science's show. So Demystified Sci. Yeah. Do you guys
we're open to other names as well.
Yeah, we just can't use Demystifying Science. It's been stripped from us.
It has been
and let's talk about this. So you guys got a whole bunch of really great. I watched the most recent one too with these 2 economics guys that should have won the Nobel Prize for economics, but they give it to the 1%, the people who defend the 1% instead. That was epic.
Yeah, those guys are badass.
Yeah, those dudes are absolutely incredible, man. And you know what? Like if we ever do create free energy or anti-gravity and the Sweden calls me in the middle of the night to tell me I won that prize, I'm going to tell him to shove it up Henry Kissinger's ass.
Did you win one as well, or is that just do you just not like Kissinger?
Oh yeah, well he won as well. He won the Nobel Peace Prize. So basically, yeah, if he can win the Nobel Peace Prize, and these 1%er economists are winning these prizes. Like, yeah, I'm all set with that, with that prize and whatever it means. It doesn't mean anything to me.
I mean, what's really cool about Mike Hudson is he's gone back into like deep ancient history and looked at the successful economies and looked at what people did in order to not, drive their populations into privation and strip.
Yeah, it's just crazy what's going on right now. But these guys nailed it. They hit it so hard. They hit the nail on the head, like with that explanation, man. They explained so many of these terms, like I don't even know. I have to write them all down in vocabulary. It sounds like something you should teach to every high school student in America and have them like write these vocabulary terms down and take a test.
I think most people just don't understand how much unearned income contributes to the main market, this GDP business that everybody talks about. The economy is doing great. The GDP is up, but it's like, it's really just this financial sector siphoning off all the wealth from the normal people. And they count that as growth economically, but it's really driving us into privation. Like, it's really, really hurting. But you can't see that in this marker. And
right.
So
and
it's a really Weasley tactic.
Bidenomics.
I mean, it's old. This is old, way older than
I know it's older than that.
Babylonian almost.
Oh no. But that was great. When did you guys switch over? Because I remember I did an interview with you a long time ago, and you were using the Muppets.
Right? Okay, I was thinking that. I was like, her voice sounds so much like her. It must be.
Yes. Yes.
It was too hard to make. Like, we couldn't make eye contact with people. It was really hard to connect. And
we were not puppeteers. I think that was
we had homemade puppets. And
I thought you guys did great.
I really.
It also hurt.
That. I remember we talked to you, didn't we? Like, we had like a whole thing. You like showed us around your lab and all the like alchemical stuff you were trying to do with
yes,
silver.
ma'am. Very true. I was with you. I do recall. It was good. Good to see you guys again, and looking very professional, by the way.
I wish I had a tie.
More human, at least.
Yes.
It was
when was that?
Alien scientists that were alien puppets, correct?
2 years.
Yeah, I think there's still a few videos on this. This is a brand new channel, actually. Well, not brand new, but new since then. I think we have a couple of those puppeting videos at the beginning of this channel.
Mickey and Quinn. That was it.
There it is.
There it is. Yeah. Okay. Well, that's why you got to have content. What happened to the old channel? You didn't have the continuity. You just got to keep one channel and just got to plug away at it and keep away at it. You know what? I took a huge break in like 2014 and I didn't do any videos for like a while. And that was like the time of massive growth for YouTube. And I'm like, man, I'd be like one of the huge channels now if I like didn't go away for those key years. And I just stuck with it. But
you came back once they were shadow banned or shadow banning.
And they like really abridged access to a lot of topics. And I was looking through your videos and I was like, man, I wonder if you made those videos today. I bet that YouTube just wouldn't feed them to anyone.
Yeah. They don't. Like, a lot of them are hard to find. You won't find them in the searches. Like, you can search the exact name and all the titles and it will still be on, like, you'll have to go to page 100 to find it. It shows like they really messed with the algorithm and stuff and broken a lot of the smaller channels and whatnot. But this is this is just a treasure trove of great guests and stuff. And I do like the more professional podcasts, although that was fun with the aliens. It's definitely easier to connect with you guys as humans.
It just gave it a weird vibe because everybody thought it was a children's show, and so we'd have these people that were working on really complex science, and they would show up and they would think that they were having like PBS Storytime or Sesame Street or something.
That's fair. That's
yeah.
I think it was hardest on the guests, and it was very difficult to try to find new guests and try to break their hearts with the fact that we were going to be puppets, and it just wasn't worth it.
And I just remember Pierre Marie, who's basically our science dad at this point, saddest dad. We had him on for I think 8 hours, and we talked to him, and he told us everything about solar physics. And then afterwards, he called us, and he was like, "You have to stop the puppets. Like, you can't keep doing this."
Yeah.
You're like, if you were deformed, I could understand, but you guys aren't deformed.
They're good-looking people, right? Like,
No.
I've got another name though for your podcast. If you do want to change it, you could say The Science Between Two Ferns.
Are these ferns? I guess so.
Palms, technically, we actually debated for a long time if we should
guess
do the
they are.
palms because they were so it could be seen as derivative, but they were the only plants available at Home Depot.
I do love that show though, for what it's worth.
Sure, yeah.
We cannot rival it.
We actually we have to
Rival it on a
constantly rotate
science
them out.
sense.
What was that?
I mean, yeah, it's funny because maybe we thought about calling our show Science Dicks because we just bring on physicists and pick on them or something. I guess that would be closer to Between Two Ferns.
Yeah, it's like it's Sesame Street for physics.
But aggressive.
Yes, aggressive Sesame Street physics.
Well, Salvatore wants to start what we dubbed mixed mental arts, MMA physics, right?
Yep.
So that would be a good podcast as well. Since I showed you guys around my lab before, I want to just give you a little bit of alchemical discoveries I've since made with my monoatomic gold that's white. When I put it out in the sun, it now turned purple. And I found also that while making monoatomic gold with pure 24 karat gold anode, pure 24 karat cathode, that it'll make the white monoatomic during the day when the sun is out, but as soon as the sun set, it starts putting black goo out instead of the white monoatomic. And the ancient alchemists tied gold to the sun, so it's like here seems to be this physical attribute with it. And then last time I think I mentioned with the monoatomic silver, it seems that the production rate of it from pure silver cathode, pure silver anode, the amount of monoatomics being produced was tied to the moon cycle. When the moon's waxing and waning, it barely makes any. When the moon is full moon, it makes a bunch. And the couple times I've had it during a super moon, it literally filled the bucket full of this monoatomic stuff. And I went so far as last year with Jeremy on his Alien Scientist channel during the eclipse, we did some experiments and I set up the monoatomic silver where before the eclipse, it was making a whole bunch. And then as the eclipse happened, it stopped making any live on your channel. And then it continued once the eclipse was over. So very, very fascinating, these energies and what the ancients tied to it.
Yeah, I know gold's a good monatomic gold's a good absorber in the IR. They have to use it to make black bodies if they want to do IR spectrum black bodies. So I wonder if it's something up there in the upper wavelengths that you're seeing in that reaction.
Could it be UV?
No, that's low, right? That's low wavelength or tiny wavelength. I'm talking about big long ones.
Sure, but like UV would give you a lot of energy because so monatomic substances are like fully dispersed in solution, so you have to break them off the lattice.
I was just talking about Pierre was literally just texting me yesterday about how he was like, there's something really interesting here with gold, like in terms of he thinks that it has to do with the protons in the black body contributing to the black body spectrum because you're making these heavy elements are necessary in order to cover the full basis of the black body spectrum in the upper wavelengths, essentially. I don't know. It's beyond my pay grade, but it's something to consider.
But like if you're seeing differences in the way that the
moon's beyond, I have no freaking idea how that's involved.
But the moon bounces sunlight.
It does.
Wouldn't you expect there to be, and the strongest component of sunlight is UV, isn't it? Or is that not right?
I don't think so. No, I'd imagine it's I would imagine it's less.
Really?
Right. So demystifying size, I had to bring it up because this is straight mystery. And then you bring in the fact that like there's the woman's menstrual cycle tied to the moon. You have any doctor or ER person will tell you that lunatics come out on a full moon, and that there seems to be some sort of bigger power energies coming from the celestial bodies somehow.
Well, that's definitely got to be linked. I mean, there's cycles that are happening that are pushing and pulling people around. I wouldn't be surprised, right? Because it's like you're affected electromagnetically and gravitationally by the planets.
Like one of the smartest physicists I've talked to believes in astrology, and I'm like, how does this make any sense? And but if you think about maybe if like the alignment of the planets could kind of cause certain kind of cycles and stuff with
Right. Well, from physics point of view, they are the largest masses in our physical realm acting on each other with their gravity and the EM fields that, if it's tied to bioenergy somehow, that it would make sense, I guess.
Does the
I mean,
Earth's
the problem
magnetic
is that like
fields-
something even like Jupiter, like by far the most massive body in the solar system, like more massive than all the rest of them put together other than the sun. But you got to think gravity falls off with an inverse square. So the effect, like if you were standing on the surface, well, the Jupiter doesn't really have a surface, but you're standing on the surface of it, it'd be like crushing gravity. But the effect of that gravity on us here on Earth is like, I don't want to put a number out, but I think it's something like 1/60,000th or something. It's like an incredibly low force, basically.
Question about that. What about the moons of Jupiter? If you're standing on a moon of Jupiter, how much does the gravity of Jupiter affect you from the moon?
That's a good question. I mean, they're still spherical, right? Like they're not being like totally elongated by it, so it can't be too.
Wouldn't you be in free fall though? Because technically the moon's falling, so I don't know. But it's gonna have, but it also, like imagine if you had oceans on the moon, would they have tides? And would those tides be even more like strong? Because I mean, they're affected by Earth, the gravity. It's way bigger.
Well, is Io Saturn or Jupiter?
Yeah, I was gonna say Io's kind of. I think that's what Io is all about, right? Because it's got all this magma that's getting squished out of it by the tides, right?
Exactly. Yeah.
Crazy volcanoes and like, I think it's volcanoes are like amplifying the magnetic field. There's like this entirely wild system of feedback going on.
If we
Io is very alive.
Academia to apply some real quantum physics to this horoscope astrology business, we'll have Schrodinger's horoscope. Man, yes.
I'm trying to figure out if there's any effect of the lunar cycle or the solar cycle on the Schumann resonance or on the Earth's magnetic field, because those are probably the only two ways that I can imagine there being something that's transduced. Because I know that we had this lady on the show who was talking about quantum biology, and she was talking about this guy who builds really good Faraday cages, and he has a lab in France, and he's discovered that if you put tadpoles inside of a Faraday cage that cancels the Earth's magnetic field, they develop weirdly. They're mutated. So you have to have the proper magnetic field in order for the embryos to be able to actually move into the right position and to actually form the tadpoles without their heads and stuff being in the wrong place. And so if that kind of a small absence or presence is necessary, then you can imagine that a small variation in just ambient conditions would generate.
I can imagine all the stars. I can imagine all the planets affecting the sun in some way too.
Not good on the Wi-Fi front.
All right.
No, he was asking like if that's the case, how's Wi-Fi affecting us? And I was like,
not good.
Yeah. What were you trying to say then?
I was just saying that I could imagine the resonance of the planets, like the alignment of the planets affecting the sun, in particular its magnetic field, and so the solar wind, and so all the downstream effects of that on our own lives here. I don't know. I'm always looking for this. It's funny because like I teach this basic intro astronomy class at the university, and the textbook uses astrology as this like demon of anti-science, and it's really interesting to go through that with people because a lot of people believe in, more people I would say believe in astrology than believe in science. It's like a really popular thing, especially throughout history. But
it's like I've experienced this where I can like pick up these random astrology books that were written like 50 years before I was born, and it's like you flip to like your exact date and stuff and like the whole alignment. It's like, how the heck is this thing defining me? And then it's like it becomes pretty hard to not believe in it in some way when the majority of the time they seem accurate.
I guess like one of the other punching bags is that the astrology calendars were set up 2,000 years ago or 3,000, 4,000 years ago. And so the stars are actually like the pole star, for instance, has moved a little bit. So all the stars are like not quite right, just due to the precession of the Earth. And so you're not really in the astrological sign that your chart says that you're in.
You're in the wrong house.
Yeah, something like that.
Well, they're written to be sufficiently generic that they apply, right? It's like this is how mediums. Jeremy, what
Yeah,
is
that's
the
true
thing that
too.
you're showing?
Oh, I don't know. It's I found a Schumann resonance generator on eBay. It just looks
Yeah,
like
that's what the Schumann antenna looks like. That's the geometry of it. And then you see some of these ancient drawings that literally look like they have these Schumann generators on them. It's crazy. And that they're built into floors, the mosaics of floors in lots of cathedrals as well.
Oh man, when you were talking about the gold, I was thinking about the cap on the Egyptian pyramids too. We had this dude that he presented this really out there theory, and it sounded like almost too out there for us to even entertain, but it turned out to be really compelling that there was this industrial chemistry going on inside of the pyramid, that the structure of the chambers was basically uh, more appropriate to industrial chemical manufacture than anything else. And they were basically doing the Haber-Bosch process of making ammonium fertilizer and all of the downstream chemicals that result
And he
from
goes
that.
through it, and he's like, they've literally never found a body inside the Great Pyramid.
He's like, that's not a sarcophagus, that's a vat for chemicals. But it's like, it was such a compelling presentation. Actually, that's one of the podcasts. I don't know what number it is, but you guys should check it out.
Jared, what was his name? Jeremy?
Yeah, we should look it up.
It was really funny because Shilo booked this, and he tells me as we're going into it, he's like, hey, we have this guy who's studying the pyramids and about how they were producing massive quantities of industrial chemicals in the pyramids. And I was like, are you fucking kidding me? Like, like this is
interesting because then like I remember I read one of the books I read a long time ago is Christopher Dunn, the Giza power plant, and
we have him coming like next week.
Oh, I just remember this guy's channel. It's called Land of Chem. Check it out on YouTube. Yeah, Land of Chem.
Yeah, he wouldn't do my podcast. I don't know what's going on with that. But
Christopher Dunn?
He went on Danny Jones recently, and so yeah, he had this whole theory in his book that there's the Queen's chamber was like they took like grape juice and something else, and it turned into hydrogen gas, and that the hydrogen gas would rise up into the King's chamber, and that the King's chamber had this resonance hall of the Helmholtz resonators inside the Grand Gallery right here. That would create these microwaves or sound waves that would vibrate inside a resonance chamber inside the King's tomb, and that this resonance of the hydrogen gas inside that chamber was somehow a fusion reactor. But then I don't know how they get the power out or where it went from
arc, the missing arc that fits perfectly into the box in the King's chamber. And I've been talking about this, that Egypt, because originally it was Chem, the land of Chem. They renamed it, and it's like Egypt. They've been gypped out of the energy. It was stolen by Akhenaten or Moses when he took the ark from it, which fit in and was the giant capacitor box. And John Hutchinson has made the replication of it in Japan. I think it was like 10, 20 years ago. And like they were getting mad power out of this ark that they replicated.
Interesting. I mean, God knows how old that thing is, right? It's like, how do you even date a bunch of rock? What's the does anybody know the standard way that they give the pyramids their date?
Oh, they find wood.
You find wood?
They find wood that's like buried in the pyramids
from their construction.
So they date it by the kings that they claim, or the pharaohs they claim that were buried in it, right?
There's a king list, but in addition to the king list, they also have radiocarbon dated wood that they believe was used as scaffolding in the construction. And so somebody made the really good point the other day where they were like, what stops people from just digging up the pyramids another 10,000 years from now and finding, a dead camel or something next to it?
Plastic.
Right? Exactly. Like they probably did renos at that time, and it was the resurgent Egyptians, or like the I forget what the newer dynasty, or like the most recent dynasty, that then like went in after this cataclysm, found it, renovated it, chiseled their own stuff into it, and then reused it. But the original builders most likely more advanced from this pre-cataclysm time.
Dude, did you see this pyramid they found in Indonesia? It's like 20,000 years old or something.
Gunung Padang.
Yes, that's what it is called.
What the heck is going on there?
Before we move on from the idea of dating, I think that we should have more of a troll mindset, and we should just start to build false monuments, and just like build shit and
Like a fake pyramid?
yeah, like or
Like Vegas.
intentionally fill the pyramids with artifacts that are anomalous, so that 10,000 years from now, when they do excavate it, they're like, "What the fuck is happening?"
Right? I like that. Kind of like a Crespi collection.
We spend a lot of time being like really dainty about, how are we going to leave things for our descendants to discover so that we maintain our wisdom. And I'm like, why don't we just accept fear, uncertainty, and doubt and sow it through the ages?
Well, so one part that I have an issue with of them being like, oh, we were just hunter-gatherer, right? There's just evidence of hunter-gathering, but it's like, well, like you say, 10,000 years from now, all our cities are on the coast pretty much, get wiped out by something. Right now, we still have indigenous tribes that don't have contact with modern civilization, that are still hunters and gatherers, that are just out there doing that. And that's like what you would probably find most in the land remaining if the oceans have gone up even more and all of our cities are underwater out there somewhere, right?
Yeah, and you got to think about like what are the stories those people would tell about all this shit that's happening right now? Like, what would that look like in an oral tradition 10,000 years later?
Because I don't think there's any tribes that are like full stop uncontacted, right? Like,
I mean, they probably see airplanes flying over at least, right? Like, they probably have some sense that
Like,
there's
what is that dragon in the sky?
we had this really crazy experience where like out near Joshua Tree or San Diego somewhere, and this airplane flew over. We were just like hiking in the woods, and all of the coyotes started howling at once as the airplane flew over. And it was like, what the hell are they thinking? Like, what does this mean to them? You know, they clearly
Pretty
wanted to
cool,
communicate with it.
actually. That's a fascinating experience.
I formulated an entire theory on the back of it that like mythology actually runs much deeper than humans, and all of the most fundamental stories that we have began when we were still animals, but I have no proof of that.
I feel like that's kind of what we're doing with the UFOs. We're sort of just like the coyotes howling at these things, like no real basis for understanding what the hell they are, but try to put these stories on them anyways.
Well, when it comes to that aspect and like just intelligence, one thing that always baffled me was I had a couple of little chameleons, and I was feeding them crickets, and like that these crickets like burrowed into the moss, and then I put in a couple of waxworms, and when a waxworm dropped, these crickets popped up on different sides of the tank, chirped at each other, and went in together and pack attacked, killed, and ate the waxworm.
Damn.
And it's like, how were these little bugs intelligent enough to communicate and then pack, hunt, and attack something, right? Like we claim like, oh, a golf ball sized brain, you couldn't think of anything, but yet these little crickets with a pin prick of the size of a brain were able to do that.
Yeah, we don't have good systems for being able to understand how organisms that don't have complex brains can do stuff. And so you see people all the time being like, well, they're just not conscious, which is kind of what they also do for early humans too, right? They're like, well, they couldn't have thought things.
You know, some guy on our podcast said like he didn't think his cat was conscious. You're like, what? Really? You don't have a very good relationship with your cat, dude.
Right?
I think it's just kind of an ill-defined term, though. It's like, what the hell do you mean by consciousness and everything? And I think most people probably mean something like self-consciousness, which, I don't know that the crickets are grooming themselves in the mirror and stuff.
Oh, there was a study that I found the other day that like they're doing brain scans of like chickens and rats, and they're showing that rats can think about things that aren't in front of them. Like they can think about places where they've been, and chickens can think about places where they've been, which starts to challenge the very idea that they can't. How are they doing the experiments? Yeah. Probably a really bullshit method like fMRI or something.
Yeah. I don't know how you know what a cricket's thinking or a rat. I mean,
right, but like even dogs though, like my pet dog in the middle of the night, it's like dreaming, it's like yipping, it's barking, it's like trying to run in its sleep, like it's conscious dreaming. Like it's got a subconscious clearly then as well.
Yeah. So I'm looking at this this Gunung Padang press release, and so they've finally radiocarbon dated it, and they found that the older parts of the structure are between 25,000 and 14,000 years old.
That's amazing. And
That's like
didn't
during
they
the
also
Bronze Age.
find like a working energy something, like some sort of working energy signature still inside the cavity in the very center of it? I remember, I believe Graham Hancock doing something on.
I don't know. Jeremy, do you know anything about this? I'm trying to figure it out.
Jeremy, you're muted if you were trying to talk, brother.
There's
No, sorry, I hadn't heard about it. This was so sorry. I was reading comments and stuff. So just rewind.
Where's this at, by the way? Is this
Indonesia.
Indonesia?
Yeah, it's on
I mean,
like
what's
the
crazy is
northern
it
tip.
kind of sits right between. So we have all these pyramids in Mesoamerica, all these pyramids in Egypt and Sumeria, and then
Also Asia though, China, Korea.
sure, yeah. I don't know if you guys saw this. We had this dude from UCLA, this archaeologist, who was investigating this site in China, and it had this unbelievable artwork that was like very, very Aztec Mayan looking, but it was apparently dated to something like 1,000 years before the Aztecs and Mayans were making this same artwork. But it was very, very strange in terms of like a potential missing link between those two cultures, and he wasn't totally opposed to that idea. He wasn't willing to, he you know how academics are, like you can't prove it, but it really, really looks like a Mesoamerican facade just in the middle of China from 1,000 years too early. Very, very interesting.
That actually kind of corresponds to a podcast I did last night with Hans Dietrich, and he is talking about in Egypt that there's one grand hall, I forget where it's at, but you pay the guard and you go into this room and you're like, what's so special about this? And then he shines the flashlight onto the roof, and on the roof there's this giant Mayan Aztec like painting and relief on it, and that Maya in Egyptian means ocean. So like Maya crossed the ocean, well, you would have the Maya people there.
Wild. Yeah, there's a lot of shared symbolism too between the Middle East, let's say, and the Mesoamericans. There's like the serpent god deities are similar. This handbag thing you've probably seen shows up in both places. This little basket that they're
Yeah, that
around.
handbag everywhere, right?
Handbag's crazy. Some of those comparisons side by side are just like, what is going on?
And the watch looking thing usually on the wrist of the guy holding the handbag in one, and then the pine cone thing in the other.
I know the pine cone. I don't know about the watch thing.
I haven't seen the watch. Yeah.
Oh, you never seen the watch with like the flower petals on it? It's like on all the Sumerian guys and stuff, but they've also found it now on some of the Peruvian and Bolivian ones too.
I know they got that tree of life thing. I mean, it's funny because you talk to these academics about like what the hell's going on, and they're like, well, they were licking the same toads. It's like, so they saw the same. I'm like, dude, I don't know how many toads you've licked, but I'm not seeing these like, I haven't licked any toads either, but it's hard for me to believe that people are just coming up with the exact same art designs just by, tripping on the same drugs. But that's the standard narrative, I guess.
Yeah. Brings up a memory of took a picture once when I was like at this famous music festival, and I like grabbed a toad and I like stuck my tongue out and I like had it from an angle where it made it look like I was licking the toad, but I definitely was not, and I posted it and everyone it was funny.
That's really funny.
Sorry, yeah.
I hear it can be quite dangerous
Getting a
licking
little
toads.
fringe, so maybe we should circle back to some energy.
Yeah, don't pretend to lick toads.
And one free energy thing, sustainable, that we've been working on that we got to get back on is John Hutchinson with his wife Nancy and their crystal battery cells. And that it ties back to what Perone was talking about in these crystal lattices and going into the cold fusion aspect. And then Salvador Payas being like, this new science needs to be on entropy, on creationism, not destroying and destruction, not exploding, but building.
Do you guys know anything about lattice confined fusion?
Yeah.
It's kind of a cool principle. NASA's very mum about it. There's one paper it's one paper and some bulletins surrounding it, but it's an ambient temperature fusion reaction, and very, very intriguing stuff where you basically just trap the fusible elements inside of some sort of, neutral lattice and then squish it with a laser. And it seems pretty promising. I think from the preliminary reports, it seems maybe it's so promising that they're staying quiet about it. We tried really hard to get somebody from NASA to come and talk to us about it, but just got
Nothing,
lost in
huh?
bureaucracy.
They're like,
Yeah.
nope, it's at normal temperature, so we can't talk about this. Any fusion at normal temperature, no.
Yeah, it's really funny. Whenever we talk to NASA people about something they don't want to talk about, they're usually just like, hey, talk to this guy. And they like CC somebody, and then he's like, no, talk to this guy. And then they just kind of like toss us around the office, until we get tired. And that's how it ends usually. So
Yeah, no, don't look into anything fusion that's at normal temperatures. No, just we have to go hot fusion, trillions of dollars, and it's a decade away from now. All right, just go.
My thought about it is, I'm like, if there is a chance that low energy nuclear fusion is possible, then the government's already working on it, and they're working on it in a secret laboratory
for
that
sure.
none of us have access to. Like, nobody knew about the Manhattan Project. I don't know why we think that we would be able to know about anything that is behind the scenes high-tech government.
Except for that one Nazi spy.
A Soviet spy, I think. Was he Nazi or Soviet?
Rosenbergs, yeah.
British dude.
Well, the Rosenbergs, yeah, they sold out a bunch of stuff to the Soviets, but I think that if I remember
There was that British dude in the movie, Oppenheimer.
there was somebody in the Oppenheimer movie who had gotten through into the inner circle.
It's hard to keep secrets, man.
It is hard to keep secrets, but I feel like we're better than ever at keeping secrets. Everybody's so surveilled. Everybody's technology is
Right? I was
constantly
gonna say,
watching
with
them.
the smartphones of today, it's like it's hard to keep a secret for anything that's public, but if it's private, they're gonna make sure it stays private. It gets expunged, and so do you if you talk about it.
Right? Like they could just have like an underground city where they just like basically took
Cleveland, Ohio, man.
Is that
That's where those guys are at. Yeah, it's like some innocuous middle of nowhere place.
That's where the hive is from. Oh gosh, what are those movies? Zombie ones with the Umbrella Corporation.
Well, right, Pat's out there too, right, with all of the alien autopsy business that was, sort of whispered about. I don't know. Big Air Force base in Ohio, for what it's worth.
Lots of dumbs everywhere. We would be dumb not to suspect that there's some real hidden science going on in those dumbs.
That to me, it seems like most of the UFO stuff is, my instinct is government technology. And like, governments have something that they're testing and it's not familiar to us. And because all of the whistleblowers that come out are mysteriously unspecific. Like, nobody's really been able to offer any kind of hard evidence. Nobody has photographs. Nobody has anything that they can point to. It's all hearsay. And I'm like, if it's all hearsay, is it possible that it's just disinformation to cover for something that they're building themselves?
Right, that's what it seems like with these Tic Tacs. And if the Ashton Forbes case that he's presenting is true, that's what it is, 100%. And that why I give this MH370 Tic Tac videos credence is that they're the same Tic Tacs that the Pentagon has acknowledged existed with the Nimitz encounters and whatnot. So, they seem very, very similar.
Yeah, can you lay out the Ashton Forbes stuff? Because I've only really tangentially seen it, and I don't know much about it.
The thing I really want to see is, well, I want to know what kind of FLIR, thermal imaging cameras they had back in 2014. Obviously we have some better stuff now. So whatever we have back then, someone's got to have it or show it. He mentions like Raytheon, and there's a bunch of other companies that have developed this technology and stuff. But I'd really like to see, what does a commercial airline look like on those cameras or on those sensors, because this is kind of like, if those videos are real, then that's sensor data from the satellites and stuff. So it's going to show us some of those things. So I'm interested to see, well, what does a Bose-Einstein condensate, or what is a superconductor? We can get some yttrium, barium, copper oxide and supercool it and see what it looks like on thermal cam, just so we can compare it to what he's saying is in those videos. You know, because I don't know, the videos, it's like, it's hard to say with the video alone, because I'm just not convinced. There's so much you can do with CGI and people who
Oh
are
man, there was this crazy article that came out in Forbes magazine right around the same time that was essentially a spotlight on this defense tech that was being developed, you know, by a contractor for the U.S. government, and they were essentially developing these heat signature holograms that they could project from satellites.
yeah,
right?
yeah.
And you guys can go look that up. Like it's wild to read it because it sounds exactly like the TikToks. Basically, they're TikToks.
Oh, so it's just like a psyop of essentially. Then
It's like maybe they and they were like, let's try this out on our own fleet and see, you know, because
yeah, right. That
Yeah, yeah. I
don't
mentioned that,
actually
and I
have
get all
that
these people
technology
attack me and
for
say they
hologram.
would never ever test that out on a live fleet.
Oh,
That's
come
so
on.
illegal and so wrong. And I'm like, dude, they fed radioactive meals to prisoners during World War II to test the effects of radiation on
They
soldiers.
gave acid to like populations in the
Yes.
water. Like,
Yeah, they sprayed
This is
bacteria on
harmless
San Francisco.
technology,
Like
bro. Of course they would test that in a live
Tuskegee
exercise.
Airman.
And that's the weird thing, man. Like, because I go back and forth on all this, man. I like at that interview I did with Pays last weekend was like the first moment where I'm like, what if this is really like legit? You know, up until then I'm like, you know, this might be real. I'm just like here to like investigate it and see. And I've been super skeptical, but after that I was kind of like, man, like what if I am like J. Robert Oppenheimer and we're trying to like tickle the dragon's tail for real, or we're like chasing the beast, man. Like, man, I thought that was it kind of just changed my mind on a lot of this stuff. But yeah, as far as all those mysteries go, I think that it's it it's good to get more people asking questions and digging into those mysteries. And I think that there should be more official investigations into this kind of stuff that really try to get to the bottom of that. Like, is that guy Edward Lynn, you know, Agent 370 and all that stuff? Like, is that the real guy? You know, is it someone else? You know, like who leaked is that, you know, it was, what kind of capabilities do we have for, you know, tracking errant aircraft? I mean, obviously we've had to have put something in place, like with the satellite system, and we have the Star Wars defense program. We have some, you know, surveillance and monitoring capabilities that are not made public and well known about, but it'd be nice to know about, you know, at least what we had in 2014, you know. But it's crazy if you look into all the Argus stuff and the spy drones and the capabilities of these things, man. There's
another major part of that MH370 though, and 10 years ago in 2014 would have made it so much more important now with like is it NK whatever, the cold the superconductor at room
LK99.
and yeah, the NK99, sorry, and that there's like all of this new stuff coming out with superconductors and whatnot, and that supposedly that airplane had 20 of the like most advanced Chinese superconductor engineers on it. That's like with the whole Diego Garcia being right there, the no mention of it, and that these crazy engineers that were supposedly on their way to China to upgrade China's factories, and that if this is that cold fusion breakthrough, these superconductors at room temperature, that would have made it this target plane to use whatever technology to either save it, take it out, or run a psyop to take the people on it.
Yeah, and it wasn't, I don't think all 20 of them, there was 4 of them that were like really, you know, established and top scientists and 20 total on the flight, but not all of them were like the upper level people or really high level people. But still, it caused a lot of outrage. And you're not supposed to put all your eggs in one basket at those big companies like that. And why would they do that? Is a big concern in general. Because a lot of companies have, not had those have practices in place. Don't put them all on the same plane. Like, you don't. It's kind of like the president and the vice president they're never on Air Force One together. ever.
Right. Oh, just like how Prigozhin there in Russia and all of his main team, we're all on one plane. The one time it gets hit by a missile, and then they're all gone. Right, like the Wagner contract.
Oh yeah, there's nothing going on there. Right.
Right.
It begs
they literally
conspiracy.
had 3 airplanes where all the bosses were supposed to be on each one, flying in the air at that time, but no, they put them all onto one plane, and just magically it explodes. Right.
There's
I
like,
mean,
do you guys know about this? Like, there was some plane crash in Russia where like most, like, I don't know,
That's
like
what he's talking about, the Prigozhin.
no, I'm talking about when the Polish got like half the Polish.
Oh yeah, the Polish when the former Polish
It was like
president
a bunch of people.
and whatnot died. Yeah, and then
Yeah.
his twin brother took over or something.
It's kind of like, when all those big bankers and financial people that were opposing the Federal Reserve all got on the Titanic in 1911. 2 years
when
before they
everybody
formed the Federal
investing
Reserve.
Enron went into the Twin Towers on 9/11.
You can't write all this stuff, man. No.
I'm sure they're just coincidences.
Just
Just, random walk of the universe. I don't know. I have this weird feeling sometimes where
Building 7. Sorry.
what's that? Building 7. Yeah, exactly. I touch the edge of these things and I'm like, how does a person continue to live a normal life if you assume that these are not just coincidental things? Like, I feel like it makes it impossible to wake up in the morning and brush your teeth and go to work and work your job and do your thing.
Like, it strips you of it.
Literally where you transition into a non-player character, where you're just like, I'm gonna be a zombie in the Kong. I don't mind being a sheep being slaughtered by the wolf at the end of the day.
I mean, it's definitely. I mean, like that's what the whole idea of the Matrix was, right? Which is that you can look at reality and you can choose to just go back into the machine because you like your steak, and it's easier and it's better that way.
Right, and well, with the metaverse, that's kind of what it looks like they're trying to do here, and with the transhumanistic agenda and stuff. Sorry to get all conspiracy, but it seems like that's what the powers that be are trying to aim for us and try to put half the population into, and that then anybody that wants to be free or awake or like really awake to, hey, I pinprick myself, I'm bleeding and it hurts because I'm not numb. This is the reality that you'll be swarmed by these drones that are like, no, everything's fine. You're not bleeding. You're not dying. Nothing's wrong, sort of thing, right?
Okay, so do you guys know who Palmer Luckey is?
What's it? Palmer Luckey?
Yeah, Palmer Luckey. He invented the Oculus Rift, and I think that he's also I want to say that he's involved in like Palantir. Yeah, Palantir. He's the CEO of Palantir.
And who exactly is Palantir?
Or no, maybe I don't think he's involved in Palantir. Okay, but anyways, Palmer Luckey invents the Oculus Rift. No, Anduril. Sorry, not Palantir. Anduril is the defense industry company that makes independent systems. But so he invented this VR headset that would let you play video games and stuff, but is programmed to explode if you die in the video game.
What?
And so obviously he's never tested it, and it's obviously kind of like a troll thing to design.
But that's kind of like the Chinese military helmet that it's like, oh, if you get captured, it explodes.
Well, is that a thing?
Oh, that's a legit thing now.
I mean, I wouldn't be surprised. You can't people can't get captured. But I have this really grim vision of the future where I'm like, okay, We talked earlier about the limitations of energy and how energy is this really difficult thing to get. And
like a Hunger Games sort of video game sort of thing.
I don't know. I never watched the Hunger Games. I don't know. Maybe.
But just like a challenge, it's like y'all sign up, one person wins and get something good, the rest of you get the button pushed at the end.
Maybe. So that's one possible version. But I had this vision of basically just like people being used as computational resources for whatever AI technology or whatever computationally intensive processes have to start happening. Because if you think about what all of the technology is pushing, like Elon Musk is developing Neuralink. Neuralink allows you to record and control what's happening inside of somebody's brain. The logical endpoint of that is that you can have people who basically sell parts of their brain to use as processors in return for some kind of probably virtual
digital currency.
digital currency that they can use in some kind of video game.
Oh, that's a dystopian nightmare future.
Well, like you don't have to get the implant, you know?
True, exactly.
Oh, is that the Neuralink? Oh god, that's so
Sort of like
gruesome.
how you don't have to have a phone.
Yeah.
Is that really it? So
Like, can you really not have a phone? Can you really like?
I've debated.
Can you even really not have a smartphone? Like,
I don't know.
how's that working out if you do? I don't know.
Yeah, I used to work in a lab that was developing these like neural shank technologies, and they like the year before I left, they'd gotten with a bunch of other labs, I think they got a $20 million grant from the DoD in order to develop this stuff. And like obviously Musk is hard at work on it too.
And I don't think that the teleology of those devices was a hot discussion topic in those labs.
God, no, it was incredible. It was always just like, guys, are you sure that we should be doing this? And everybody was like, shut the fuck up.
Right? Like, who signs up to be one of the test people? Like,
well, they're going to put it on people who are, you know, spinal cord injuries, stuff like that. Like people who are desperate.
I guess so. That's right. And then I guess it is actually advancing a couple good aspects potentially.
Yeah, it's just a matter of how do you keep the bad guys away from it, especially when the bad guys are getting rich off of doing bad things.
Right.
It reminds me of that. I watched the movie recently with Robert Downey Jr. Transcendence, I think it's called. And it's about they upload his consciousness into a computer, and it makes like this AI. And the AI convinces his wife that it's still him, and gets his wife to go do all this stuff. Like basically, he makes a bunch of money in the stock market. The AI makes a ton of money in the stock market, and then finds this town and starts building this whole like structure underneath the ground and everything. And then it figures out how to like it starts giving people upgrades, you know, but like also installing them with like Borg software, and eventually like it's trying to create a Borg army and stuff. It's pretty interesting.
Dude, something's coming for sure. I don't know how it's gonna play
out. Like the whole Skynet thing, it's like, why the hell are we still allowing the militaries to implement AI technology in war and in military things? Like, how do we not be like, hey, let's make sure we don't design AI to kill people, because, you know, there's not going to be this leap of, well, if it's programmed to kill people, it's going to just start killing people.
I mean, I think the trick is most people are just concerned with paying rent, right? Like, I think the average American's like $100,000 in debt right now. So it's like, who has time to stand up and worry about these kind of things? I mean, getting Americans to get out in the streets for anything seems a dwindling possibility.
Oh,
unless they're all out on the streets because they can't afford their homes.
Yeah, that's trending.
I saw a patent somewhere which was okay. So Sony patented a device that allows viewers to skip commercials by yelling brand names at the TV.
What?
Yeah, so it's this technology that like when the ad comes on, you have the opportunity to end the ad. Like, let's say it's an ad for McDonald's. You have the option to end the ad early by standing up and yelling McDonald's, and then the ad stops. And your program continues.
Oh no! You're chanting in
Indoctrinating your
unison.
children to scream for McDonald's over and over.
I would just get up and scream Aflac.
Then it shocks you.
But that actually reminds me of Eric Hecker bringing up this voice to bone technology, and that also McDonald's, I guess, is like investing in both voice to bone advertising, so it like doesn't even go through your ears. They can just like broadcast the signal that like goes to your skull into your brain, and then also through dreams that it can broadcast it into your dreams and put advertisements into your dreams.
There's a Philip K. Dick story sort of about this this guy's got some sort of implants, and these ads are showing up everywhere that he goes, and he can't shut them off. It's crazy. He thought of that like 50, 60 years ago.
Yeah, I think that anybody who's interested in seeing the most pulp fiction-y version of the way that these things go should read Philip K. Dick. He wrote Minority Report, he wrote Blade Runner, he wrote A Scanner Darkly. There was like an Amazon mini-series of a bunch of his short stories that were
His
they're
short
just
stories
so
are
good.
so amazing.
Yeah, it's always like these dystopian futures, like with the crazy, I remember the one you mentioned there. Sorry,
Minority Report.
Minority Report, yeah, where they had the
precogs.
The precogs that could see things before it happened and stuff, and they were in these those deprivation tanks and stuff, and weird stuff with that,
Yeah, he was like strangely prescient, dude.
He has this really great one about the transmigration of Timothy Archer, which is about a colony on Mars where all of the people live these miserable lives, but they're supported because they get this really fun psychedelic drug called Candy. And the supply of candy gets interrupted, and then all hell breaks loose because they're basically screwed without it.
So is that why Biden called Z a dictator after they promised to crack down on the fentanyl epidemic?
Oh, interesting. Was that what happened?
Yes, ma'am. That was made the news yesterday. They had this breakthrough talks on China going to put all these resources into cracking down on the fentanyl trade and production, and then Biden went out and called him a dictator immediately thereafter.
That's really funny. I don't know if you guys saw that they cleaned up San Francisco almost completely in advance of that meeting.
Yeah, right? Like there's a huge scandal, like, oh, you can finally clean it up for a Chinese dictator, but then the rest of the time you can let your tech execs get murdered on the streets for...
Was that when we were there?
No. This was like last week. There's this hilarious photos of like a street that used to be covered in homeless tents, and now there's just like flower planters. And people are like, what'd they do with the homeless people? There's just none of them left in the city anymore.
Send them to Alameda.
They probably like put them in a FEMA camp temporarily, and
they're all undergoing the Neuralink upgrade.
Oh God.
They just gave them new government housing, and yeah.
No, it's
not crazy. So,
what would you say if your top 3 podcasts, if people who are new to your channel, if they're going to go on Demystify Sci podcast and check out 3, I would say the recent one you did was amazing, as is reflected in the views. But I don't know
Hudson is amazing, and I haven't seen that, so I'm gonna watch that.
Yeah, there's an earlier conversation with Hudson where it's a 2-part series, and he lays out a lot of the ideas that we were kind of picking up on in media res in this last conversation. So I would definitely go back and check out that one. But honestly, we're kind of new to economics. Let's see.
These guys, yeah.
We cover a lot of bases. So we do a lot of physics. We do a lot of consciousness researchers. We've had some really good talks with some really, really important consciousness researchers, all the way to Carl Friston and Don Hoffman. We've had a couple with Bernardo Kastrups.
No S on that, I think.
Oh, Kastrup.
We always call him Kastrups.
Bernardo Kastrup. Yosha Bach. A few of these consciousness researchers are pretty interesting. Some really, really powerful physicists too, like Carver Mead, who's a Caltech emeritus, has some really, really interesting ideas about how light works. He worked under Feynman, however you say it. He worked under
He,
Feynman at Caltech, and he's got this book called The Little Green Book. Well, it's called
Collective
Collective
Electrodynamics.
Electrodynamics. There you go. And it's a real banger of a book that simplifies electrodynamics. And so that's a good. We have a couple conversations with him.
We have a couple conversations with Alexander Unziker about fundamental physics that are really good. If people are kind of interested in quantum
Yeah, I like
biology,
Unziker. He brings it back to like foundationals and really does a lot of good historical physics, research. He's
Yeah, we just recorded one about the elastic ether, which is really interesting. There's this, I think, Irish physicist named
McCulloch.
James McCulloch,
Mhm.
and he came up with this treatment that solved a number of really interesting problems in terms of materializing electricity and magnetism. And it failed on some accounts too, but it opened up the door to a really interesting. We haven't released that conversation, but it's coming out soon.
We had a really good conversation. Number 187 is with Jack Cruz about electromagnetism's role in biology. He was a very difficult character. He seemed like he was terrified that we were gonna like shut him down or something. But if you can get past the kind of aggro narration, it's a really good conversation. And then
187, you said.
187, and then 183 is Richard Lindzen, who's a guy
That's a good one.
like a climate scientist who since the 1980s has been like, hey, I don't think that CO2 is the big problem that people make it out to be. And so he lays out basically.
He's coming back too, right, in December.
Mm-hmm.
Yeah, he's an interesting character.
You said you teach, sorry to interrupt, you said you teach astronomy, and talking about this CO2 not being it, I would love your opinion on the moon used to have ice caps, Mars used to have ice caps, neither of them seem to anymore. Is it solar system-wide heating, not just Earth?
Well, it's funny you asked that. Mars has ice caps still, and they think that there's a lot of subsurface water on the moon too at the poles. So I think that's a huge part of the reason they're sending this like van out there with this Artemis project. But it's funny you asked that because we had a podcast recently. I don't know what number it is off the top of my head with Valentina Zharkova. And she has made this really interesting model of climate change that has to do with the shift in the barycenter of the solar system. So the sun basically wandering as it's getting tugged by Jupiter and everybody. And she basically points out that, yeah, the climate change is happening on all the planets. Like you're not just seeing things happening here. It's not this simple process of humans, doing this one little thing here. It's happening everywhere. And she makes a really good case, and she's published a number of papers on that. And well, she's published one paper on that in particular, but she's got a lot of, YouTube videos and lectures about it out there.
Episode 200.
There you go.
That's awesome.
Awesome. Well, I have to end this because I'm falling asleep and I have work tomorrow. I got to get to on my schedule. This was a great conversation. I really think you guys need more subscribers, and 10K is not enough. Hopefully you guys will get some more subscribers to your channel. Guys, go subscribe to this podcast. Check out some of their podcasts.
Thanks, Tony.
Really good stuff from you two, and you did a really, really good interview with Sal Pays the other day too. So it was awesome, having to follow that up because you guys asked so many great questions. I was like, all right, it really helped me frame like what I'm going to ask him and what he can't get into. So I'm not going to waste time on that. And you guys asked him a lot of great questions. So I was surprised we even got 4 hours out of him. That was insane.
Nice.
But go check out that one. You asked some really good questions and also made some really good points. It was an excellent discussion on all regards. So
thanks, man.
Definitely thank you guys so much for coming on. And anything else you want to say before
I'm just really glad that we reconnected. It's been, you came on when we were still tiny and puppets, and I really appreciate that you've been just grinding at this and how far you've come and the community that you've built, and just it's really, really cool to see you grow and flourish, man. It's really sweet.
That's awesome. Yeah, I can't believe it's been that long since the Muppet days. That's 2 years go by like nothing. But yeah, just keep at it. You guys are awesome. You have magic, and it's been an honor to be friends with you.
You as well. And it was good
Science
to see you
between
too,
two
Brittany.
ferns. Sorry to interrupt, but science between two ferns. You got to do a little clip on that at least.
We'll do it. We'll figure it out.
Yeah, man, it's good to see you guys. We should do this again down the line.
Yeah, let's do it again. Not before too long, for sure. That was awesome.
And we'll try to actually stop by in person next time we're out on the East Coast too. I really want to see your lab up close.
Yeah, heck yeah, you guys should come by and check out the lab. Definitely, if you're ever this way. And you have did you want to plug your conference? Do you have a conference coming up or no?
Oh hell yeah.
Yeah, Demysticon 2024. It's going to be in Austin, Texas, April 7th and 8th.
Coincide with the total solar eclipse, which is passing by there. So we got some really cool speakers. Pierre-Marie Robitaille, one of our best science buddies, is going to be presenting his model of the liquid sun. And I don't know, we've got
mythology,
so you mentioned the Steve Keen from the economics discussion that you were plugging. He's going to be there. We've got some consciousness researchers, history of science people from University of Texas. Anyways, it's going to be awesome. And it looks pretty small, so get a chance to really talk to the guests and I don't know, get to hang out. 2 days talks.
If there's a website for that, do you have it? You could type it. I'll share it, the link to that real quick, and I'll also put it in the description of this video beneath so people can find it there.
It's an Eventbrite link, which is not.
We'll send it to you to put in the description.
We'll send it. Yeah, we'll send it out.
Yeah, that's all right. We'll post it below later. No worries.
Really appreciate it.
All right, guys. Thanks so much, and have a great night.
Yeah, you too. Thanks, man.
It was good seeing both of you.
Take care. Bye, everybody.
Bye.
Awesome. Thanks. Thank you. Peace out.
Peace.
Do you want to play the music, Bernie?
I can't because it logged me out of my main count. So I'm like, just
grab your guitar, Jeremy.
We're gonna rock out. Yeah. All right. That's all right. We're just gonna end it here, man. Party on, guys. Have a good night.